Welcome and thank you for joining us for this webinar presentation. We are the Cybersecurity and Information Systems Information Analysis Center, or CSIAC, one of 3 IAC domains in the DoD Information Analysis Centers operating under the Defense Technical Information Center, DTIC, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. CSIAC serves as one of the premier information research partners and curators of technology advancements and trends for the cybersecurity and information systems community. As such, our organization supports those working in the cybersecurity and information systems domain of DoD research and engineering. We do so by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. With an understanding of the cybersecurity and information systems DoD research and engineering landscape, we provide research and analysis services. We help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We hope you enjoyed this webinar presentation and that it serves as a catalyst for community collaboration and improved DoD cybersecurity and information systems research.
Good day, everyone. Thank you for joining this webinar presentation. My name is Philip Payne. I am the technical lead for the Cybersecurity and Information Systems Information Analysis Center, or CSIAC. Before we get started, I would like to note a couple of administrative items. First, if you're dialed in by phone and would like a copy of the slides, they were posted to the CSIAC webinar announcement webpage. You can go to csiac.dtic.mil/webinar and find today's webinar. When you click on it at the bottom of the announcement, it will say download presentation. I'll also put a link to the slides in the chat. Second, all participants are muted, but feel free to chat using the attendee chat window on the lower right-hand side of the webinar screen. You can use that to chat with each other, and I'll be monitoring that chat as well. However, if you'd like to pose a question for the Q&A session at the end, please click the 3 dots labeled More/Panel Options to bring up the Q&A window as part of your layout. At the end of the presentation, I'll go over the Q&A for the benefit of those on the phone. I will read the questions out loud to the presenter. If you have any technical issues today during the presentation, have no fear. The full presentation will be available online. Just check back to the CSIAC website. Once the webinar is posted, the Go To Webinar button will take you to the YouTube link. With that said, I would like to introduce today's presenter, Eric Hayden. Eric is a data scientist for the Chief Data Analytics Office with the Army Reserves Command and the lead data scientist at Data Machines, where he contributes to initiatives with DARPA and Penn State University's Applied Research Laboratory to support the intelligence community. He's an accomplished artificial intelligence, machine learning, computer scientist, and cybersecurity data scientist focusing on integrating data science with cybersecurity to enable proactive threat detection and mitigation. With over 15 years of experience leading teams that leverage data science for strategic decision-making and operational excellence, he also worked as the chief data scientist at the Cyber Protection Brigade, Army Cyber Command. Eric, all yours.
Well, hello. Good morning, good afternoon, depending on where you are. Like Phil said, my name is Eric Hayden. Today, I have a presentation titled A Journey from CRISP to Atlas. It truly is a journey. CRISP started as my passion project when I was on mobilization with Army Cyber Command. The little bit of background of that is, believe it or not, Army has teams that go out to Army sites and they do audits, cybersecurity audits, and they use STIG. These are STIG, which is standardized. They come back with a lot of spreadsheets, a lot of CSV files with findings and not findings. And somebody was painstakingly opening up those files in Excel and use a little bit of PowerShell to try to compile a report. And I wanted to help out that person, and I was like, there's got to be a better way to do it. And who doesn't like pictures, right? So, and it breathes well. So why don't I take all those results and do statistical analysis and produce visualization so that if you're a threat intel analyst looking at it, or if you're a security leader, you get a bird's eye view of your security systems and where you have to focus on. So that was the motivation. And I got inspired by this project and um, wanted to expand this upon in order to take more versatile data sets instead of just taking STIG outputs. So I started thinking about Atlas, which is a really unfortunate name because MITRE also has a framework called Atlas. And I've been thinking about it, and I think I want to change it because I don't want to necessarily compete with MITRE. And I think it's going to be a losing game. But either way, like Phil said, my name is Eric Caden. I started as a computer scientist, deeply interested in artificial intelligence. I fell in love with the power of data because data is power. And, I joke about it. The number one selling point for the federal government is you just drop the phrase data-driven decision making through actionable insight. Um, so that's my favorite buzzword. But it is true. I am. Oh, I'm sorry. It is not the MITRE tool. I apologize. But I hope you get something out of it too, and I hope it's just as entertaining. Um, so about a year and a half ago, I was on mobilization. I'm a reservist, 17 Alpha, Direct Commission Cyber Operations Officer, and I served in the reserves. But about a year and a half ago, I mobilized and I worked with Army Cyber Command, specifically Cyber Protection Brigade. Um, and I was serving as their chief data scientist, doing a lot of cyber intel analytics. And we were cranking out a lot of really interesting models. At that time, getting into machine learning and using automated machine learning methodology to triage logs and input and processing threat intelligence was new. So I think I was able to shape the processes of training machine learning models using cybersecurity data and operationalizing those models in that context. So that was very fulfilling. And I come back now. I serve as a data scientist for Chief Data Analytics Office at Belvoir for the U.S. Army Reserves Command. And on my civilian career side, I am lead data scientist for data machines. I work with Penn State University, their applied research lab, and doing a lot of geospatial intelligence, utilizing large language models and other computer vision models for geospatial intelligence analysis. And it's really fun, but I have to work in a skiff 5 days a week, and any day that I get to work from home is a treat. So nice to meet you all virtually, and that's me. If you look at the right-hand side, I am a unique blend of data science and cybersecurity. So that's where my passion lies. I would like to bring in AI, ML, and data science to cybersecurity, and that's where my passion lies. I am a GIAC advisory board member, and I'm also a CompTIA subject matter expert serving on multiple exam boards. And the best way probably you can connect with me is through LinkedIn, which is indicated up top. Without further ado, it's going to be a short and sweet demo. I don't like PowerPoint too much, but I would like to get into the actual code and show you how it works. Hopefully it's a fun one, and we can talk about it afterwards, or I can answer your questions. So CRISP is a cyber readiness inspection statistics package. And as you can see on the left-hand side, this is one of the CSV files that bring back, right? So they break it down by technology area, and you guys are all familiar with STIGs. So it gives you a STIG ID, And what I'm focusing on is the status column, not a finding or open. The inspiration I took was I was looking at the data set and I was looking at the columns. It does come with NIST special publication 800-53. At that time, we were using revision 4, and there's revision 5 about 6 about to come out. So if there's any interest in updating this, I'm all ears, and I'm open sourcing this so that the greater DoD community can also take advantage of this. So in the sea of rows and rows of CSV files of findings and not findings, wouldn't it be nice to be able to visualize this and look at it and get some statistics and more actionable threat intelligence out of it, right? So that's where the inspiration came from. And if you look at the right-hand side, that is one of the output of the tool. And it automatically generates MITRE ATT&CK Navigator JSON layer file. So you can easily visualize it, and it does some statistical calculations. So it finds weighted scores of all the vulnerabilities, or at least the TTP areas that you need to focus on. So that's one output. And so the way it works is we get the STIG data, and then I primarily use Python to do this. That's a big departure from PowerShell. So it parses all the information, and it uses NIST 800-53 to map all those findings to controls. And then it also maps that to MITRE ATT&CK TTPs, so T codes. While doing that, it performs a few statistical analysis. It calculates scores of each vulnerability that are found. Weighted values lie from 1 to 10, 10 being most frequent, 1 being almost non-existent. What it does on top of that is threat actor monitoring. So the tool, whether or not you specify you want to update your ATP data or threat actor data, APT data. It downloads the latest threat intel from MITRE, and it uses that latest data to compare your own vulnerabilities to all the threat actors that have the highest match are known to use those TTPs. So that way you can kind of analyze their TTPs and prepare yourselves or look at your technology areas and harden your systems. So this is great for cybersecurity leaders wanting to prioritize, because your time and resources are limited. So if you want to get a high level overview of your system and the vulnerabilities and prioritize where to harden first, this might be one use case of it. So at the end of the day, if you look at the far right-hand side, the output is the JSON file, MITRE ATT&CK Navigator, and also the results of all the statistical calculations as a CSV file. So it gives you aggregation of all the vulnerabilities and broken down by MITRE ATT&CK TTPs, tactics, broken down by techniques. And then it produces a percentage overlap to all known MITRE threat actors, and it gives you a heat map of that, and it shows you the percentage overlap. So, and the tool also has the ability to specify, oh, I am only interested in top 5 closest matching threat actors, right? Or top N. And so that is customizable. So to sum up, it's really simple to customize, as you'll see. And then automatic data updates, data can be pulled from MITRE ATT&CK. So it scrapes the website, it gets all the data as JSON files. And you can get multiple outputs, so CSV files, Excel files, if you want to just attach to your email and send it to your boss. And also MITRE ATT&CK Navigator. So you can take a screenshot of it, download the layers, do any sort of processing you want to do. You can also customize colors in there. So if you don't like the heat map varying level colors that I specified, then you can always change that easily. In my opinion, it's pretty easy to use, but I built it, so I might be biased. And then, I said sophisticated statistics, but it does the necessary statistics to give you the information you need. And I think what's neat about it is since it can write to Excel file, I added some conditional formatting to give you colorful heat maps so that you can see it at a glance. So I've been talking about a lot of this. So we can actually go into code and see it in action. Live demos are always nerve-wracking, but hopefully demo gods are with me today and it goes well. So this is the markdown file of README. I try to go into as much as in detail as possible. This project was initially deployed to something called Alex. Alex is RCyber's Jupyter Notebook server that can directly talk to Gabriel Nimbus, which is Army's big data platform. So the thing about Alex is that it's air-gapped, so it can't reach out to PyPI, so Python package server, to download packages. So I try to add dependencies in there. And on top of that, I also compile that as a real file. So anybody can just use pip install crisp to get it on their system as well. But we also have requirements.txt files. So if you are connected to the internet, then you can easily install the dependencies, or you can create a virtual environment or use Anaconda, however you want it. Right, so this module is broken down into two sections. One is vulnerability to MITRE. So we are looking at all the vulnerabilities, and then we are mapping that to MITRE TTPs or T codes, right? To do that, we use NIST 800-53 controls. And then after that, once we have aggregated all the data for the vulnerability data, then we can use that to create threat overlap with threat actors. So that's what the repo looked like. This is DoD's level up maintained by the Air Force. And then this just walks you through how to do it on Alex. But there are some notes about data preparation, what kind of data it's expecting, but I'll show you. But the standard README file. So for this demo, I sanitized the data to show you. So let's assume that we had a site survey to Fort Caden, and we came back with a whole bunch of CSV files broken down by technology areas. So one of those CSV files looks like this. So technology area, vulnerability ID, and STIG ID, and then discussions and descriptions. But what we are interested in is all the way at the end with the NIST 800-53 revision 4 references. So we use the controls and the subcontrols to map the findings, see under status not a finding, to MITRE T codes, so that we can visualize that using MITRE ATT&CK Navigator. All right, so I have some images that I use for READMEs and some notebooks that I played with, and I can release all those to you so that you can see my thinking processes of what I did to make this happen. And if you look at these references folder below, these are some of the CSV files and lookup tables that I use to map those findings to T codes. So I'm opening this. This is open source, and I'm willing to share this with you if you're interested. And you can take a look at all these lookup tables later at your leisure. But the main focus for me creating this is I have the actual Python module called Crisp. And then, as you can see, I was in the process of converting this to Pydantic, the data model to Pydantic. So that was in progress, and my mobilization ended. And you know what happens, you know, when in the military, when somebody leaves, you know, the project kind of dies. So I'm here to present this to you so that, you know, shamelessly solicit your participation and contribution if you're interested to make it like expanded and possibly discuss ways to tailor this to your use case. So this is a pretty lengthy code, about 900 lines of code, and I try to put in as much inline comment as possible. And in the end, there's a class. I'm sorry, I'm scrolling too fast. Hopefully nobody gets motion sickness. So here I try to add class documentation to it, describing attributes and methods and functions that is involved in it. But as an analyst, so the target audience for this tool, in my opinion, was for Intel analysts or cybersecurity analysts who may not necessarily know how to use this module to create their own Python packages or Python projects. So what I try to do is I created this notebook, a Jupyter notebook. So all you have to do is just run these cells, right? And I thought about this a lot, and I think the easiest way to make this is just have them. I mean, you could do like a YAML configuration file, but you know that requires opening up another file and editing it, and you might not necessarily understand what all the syntax is. So what I wanted to do is just aggregate all parameters that I need into one variable. So literally, all you have to do, the most critical parameter that you have to change is you just have to specify your input directory name. So in this case, it's 4 cadence CSVs, as you see right here. So you specify your folder name, and it will find all CSV files. So you can name your CSV files any way you want. So it'll find all CSV files. It'll check for the formatting of each CSV file to make sure that it's not grabbing some random CSV file in there that's not a STIG output. And then this metadata is up to you, right? So however you want to name your result files that are being output to the result folder, as you'll see later. So you can specify your site name, month, and year, and then it'll append the date timestamp of when the script was run to your CSV file. So if you want to run it over and over again, you will not have any file name conflicts because it goes down to nanoseconds, I think. So it uses Unix time. So so it'll be good. So it'll all be there. What I want to highlight here is percentage of broad controls to exclude. You will see oftentimes one control matches to, one vulnerability matches to a lot of controls, or a lot of controls are mapped to one MITRE ATT&CK TTPs or T codes. So in that case, we don't, so the broadly mapped controls are not very useful in terms of analysis. So you can specify a percentage of top 25% I want to exclude from this analysis. So it's going to rank all the broadly mapped controls, and it's going to exclude the top 25%. It's only going to use the rest 75% of it. And then you can also specify, oh, I do want to include all that, and you can simply change that to false. The overlap data is used to like specify, I want to just look at top 5 threat actors or top 10. So that's what top N's about. And in case you're in an air gap system where you're not connected to the internet, then you can just set update data to false. So it's not going to reach out to mitre.org and grab or try to grab the latest data there. The rest of the configurations are configurable. I left it there in case you want to change folder names or you're not happy with the output directory name. You can do that. But I would say the only parameters that you have to change would be just input directory and whatever metadata you want to use for the output, right? So let's see if we can run this. It ran. So as you can see, that's all you have. So you can import this CRISP module, and you can instantiate a object passing all these parameters. And then the two publicly callable functions are convert CCRI to MITRE. So that's converting all the vulnerabilities to MITRE T codes. As you see, it generated two files, right? MITRE ATT&CK Navigator file right here, and the results as a CSV file. If you see down here, this results folder was not there, and it created it for you. And under vulnerabilities right here, we have this JSON attack file or Navigator file that's been generated for you. We're going to take a look at it in a bit. But also here, the CSV file that's output, it tells you how each control is mapped to which techniques and IDs. What is not included in here is frequency, right? So as a future project expansion, it'd be nice to see how many occasions each control mapped to MITRE TTPs. But let's take a look at this JSON file. So to have your creative juices flowing, you can host this. I have plans of creating a web app for this by integrating MITRE Navigator because it's also open source. You can just spin it up on your own system and do it. For the purpose of this demo, I will use MITRE's official website. And if you look at it, you can create a new layer, of course, and I'm sure a lot of you have done this in the past, but they also give you an option to open existing layer, right? So since we have that Navigator JSON file generated, we can update from local, we can go to results, vulnerabilities, and it can upload just JSON file. And this code has not been looked at in a long time, so it uses a previous version of Navigator. We're just gonna not upgrade it, and it displays this color-coded JSON, it converted that JSON to color-coded Navigator output. So as you can see, it's very colorful. If you go back to the code, I have this legend down here that explains the severity or density of it. So 10 being most frequent, and 0 being non-existent or not available. So that's one part of this CRISP project. And then also we can generate thread overlap by just calling calculate APT overlap. And if you look at the code, even if you specify that you want to update the APT data, it's actually going to check internet connection first. So if it cannot reach out to the internet, then it's not going to do that. It's going to try to use your local files that I also include here, which is just the web scrape of MITRE ATT&CK APT or groups section. And then, so let's go ahead and do that. As a result of this, it's going to create another folder called the APTs. And as you can see, since I specified top n is 5, it's going to generate a separate CSV file just taking those top 5 APTs that you specify. Of course, if you set that n to 10, then it's going to change it. It's going to give you 10 of those. And then if you go down here to results, now we have APTs folder. Expand upon it. This is going to be your top 5. So the Fort Caden is APT 29, 28, 41, Kimsaki, and Wizard Spider are the top 5 closest APT matches, according to the vulnerabilities that we found during our audit. And then the advantage of having an Excel file is now we get to see this. The heat map of this, right? So it's all color coded. You know, the darker the color is, the higher the match is. It gives you weighted percentage. So there are many groups. So if you add them all up, they should add them to 100%. And as with CSV files, since Excel files can have tabs and extra sheets, I give you top 5 output based on that. So that's the gist of CRISP. And I want to go back and say why I call this presentation a journey from CRISP to Atlas. Atlas is automated threat landscape assessment system. So this chart should look very similar to the one that I presented before. The only difference is that I want to create a framework or platform that can take in multiple different formats, right? So there are many data sources that we can leverage to map to visualize into a threat landscape, right? By utilizing MITRE Navigator. So STIG was one thing, and then you can look at threat intelligence feed coming from CrowdStrike, or you can have your Zeek logs automatically parsed and mapped to TTPs. You can have Windows event logs, sys logs, all those logs coming in. I want to make it input agnostic so that however you audit your system or monitor your system, you should also be able to visualize your threat landscape in your own environment, right? So this is a rather ambitious project for one person that started as a passion project of a reservist on mobilization. But this was also presented at NIST, and Veterans Affairs and NIST are also interested in adopting this and deploying their own system. So they offered to help. And in your organization, I'm available. So if you like to work with me, I can walk you through the code. If you want to tweak it, and or you want to be a contributor, making it a bigger suite, actually making it, making that final transition to Atlas, name pending. So I want to get into that losing battle, like I said. So that this is where you can help me help you create something that we can use as input agnostic threat landscape visualization tool. I think that's all I have. I said it was going to be a short presentation. I hope you found this interesting, and maybe even if you don't use this, maybe I helped you get some ideas of how to visualize your threat landscape and enhance your security posture in your organization. All right, that's it.
Eric, thank you for the presentation. Always great when we can do a hands-on demo. I think that goes a little bit further so people can kind of see how to use the software, since this one is a little bit specific. So the Q&A is now open. Feel free to use the attendee chat or the Q&A if you have any questions for Eric. I'm not seeing anything right now, so I will start with this. So you did give out your LinkedIn. Is that the best way for people to contact you if they want to collaborate on this project or use some of this code?
Yeah, so LinkedIn is right here up top. So it's just /Eric-Caden. I also, this is not on the slides that Phil, you uploaded, but I added Data Machine's email address. So you can contact me by Army email, work email. So it's just eric-caden@datamachines.com. I guess if we develop enough relationships, then I may give out my personal email. But for now, that would be the best way to contact me.
Okay, sounds good. So I'll put another link to the slides in the chat as well. And we do have a question from Amir that just came in. He says, are large language models, open source or not, being used or planned to be used as part of this product to optimize it?
Yes, that is a great question. I'm a huge advocate of large language models. My computer science journey started as NLP, natural language processing. So, you know, LLMs have come a long way, and it definitely can be leveraged. Um, so definitely, yes, I see that as a possibility. Like even open source models, Llama, have come a long way. Mistral is really good. So we can potentially look at leveraging large language models to enhance the analytic process.
Thank you. Our next question comes from Vince. Were you able to work directly with threat and hunt analysts at CPB and get their feedback on this? Did they have any recommendations?
Good question. I gave a presentation of this to the higher ups, and we were just about getting ready to deploy it and for field use. And then my mobilization ended. So I don't know what happened to this particular project. I did a warm handoff to the existing analysts there, but that'd be interesting. I can reach back to my colleagues at CPB and see if they have been using it or if they have any feedback on it. But great question. Thank you.
Yep. Our next question from Luke. I still don't quite understand. What is the difference between CRISP and Atlas for someone who has not done cybersecurity work before and is unfamiliar with the language?
Yes. So the difference between CRISP and Atlas is that CRISP has been implemented and Atlas is work in progress. CRISP is a very specific term that I coined up for this particular use case that's our cyber and CPB used, which is command inspection. So it's almost like a rebranding of CRISP to Atlas so that we can make it input agnostic and kind of not tie it specifically um, to that particular use case at CPB. So it's more generic automated threat landscape assessment system rather than it being cyber readiness inspection. So it's kind of rebranding, expanded capabilities, and this is my version that I want to release to you guys, not CRISP necessarily, so that we can develop this into a much bigger project. I want to emphasize that I don't want to compete with MITRE, so that name might change.
Thanks. Next question from Lauren. Can CRISP and Atlas be applied to operational technology environments? Maybe mapping to MITRE ATT&CK for ICS or just IT?
Yes. So anything MITRE can do, so ICS and mobile and other technology areas, it can be done. So it should just be able to, you would have to create that mapping lookup, but it wouldn't be a heavy lift. But for now, it's optimized for enterprise. But ICS can definitely be also implemented for this.
Thank you. Next question from Madhavan. How big is the data set?
So data set is not really big. So it breaks it down by technology areas, and I'm not super familiar with the audit process of it, but if you look at the CSV files, there are only like a couple of megabytes per technology area. So data set's not that big, and even the reference folders that I have, properties, is about 2 megabytes. So not big. The project itself is about 15 megabytes.
Great, thank you. And I saw during the presentation you mentioned the lines of code around 900 right now.
Yeah.
What you said? Okay. All right. I'm not seeing anything else in the chat. I did put another link in the chat to the slides. And like I said, this is recorded, so it'll be up on our YouTube page by tomorrow. And also, if you check back to the CSI website, it'll point you to the recording as well. But if there's nothing else, we'll probably end it a little early today. Eric, I'd like to thank you again for your time and the slides as well as the demonstration. Definitely reach out directly to him or you can reach out to CSIAC and we'll put you in contact with Eric. Hopefully this presentation gets some legs, and this is something that we can kind of expand on for the broader use of the community.
Yeah, I just saw one question. Can I use CRISP now? Yes, if you have the data set that's formatted that way, you can use it immediately.
Great. All right. I wish everybody a happy Memorial Day weekend. Hopefully you tag in with CSI next month for our next CSI webinar. That should be posted soon, and we're just finalizing the date in June. And as always, on the way out, make sure you fill out the survey. If there are specific topics that you would like to see us present a webinar on, or write state-of-the-art reports, journals, and things like that, please feel free to reach out.
Thank you all for attending.
All right. Thank you.